Hello there once again. Today we're going to look at some trigonometric functions. These functions, you probably learned them in GCSE a bit in the higher section. You need them also for A levels. So this is a very important lesson if you're planning on doing your A levels, and this is needed also for your GCSE highers. Alright, so I'll just write out the heading: trigonometric functions. There are three main functions that you learn for GCSE. Those three are sine, cos, and tan. Alright, now the sine function is defined as the ratio between the opposite side and the hypotenuse of a right-angled triangle. So if I drew a right-angled triangle, you have a right angle. A right angle denotes 90 degrees. So if I choose an angle, it's important that I choose an angle out of the other two angles. So I'm going to call that angle theta. Theta is a letter from the Greek alphabet that is commonly used to denote angles in trigonometry. So the side opposite that angle is the opposite angle, and the longer side of a right angled triangle is always the hypotenuse. Okay, so the ratio between the opposite and the hypotenuse of a right angled triangle will give you the sine theta. Okay, now I'll just show you what that means mathematically. Alright, let me just get that. Yeah, let me draw another right angled triangle, and I'll put some values to its length. I'm going to call that 3, call that 4. I'm going to say that's theta, and that length is 5. Okay, now this is a right angled triangle, and these values here I've chosen, they are not exactly imaginary values. These values are quite valid. I know them for sure because if you did the Pythagoras rule on this, you would see it all balance out. So I'll just do a quick detour from what I'm trying to do. So if I do 3 squared plus 4 squared plus 5 squared, that's equal to 25, and that's equal to 9 plus 16. So that's 25 is equal to 25. So that shows that's a right angle triangle. So that's what you do to test whether the triangle is right angle or not. The square of the longer side is equal to the squares of the other two sides, the sum of the squares of the other two sides. So this is indeed a right angle triangle. So if I do the sine theta for this angle here, that would be 3 divided by 5. So the sine theta value of that angle there is 3 divided by 5. Alright, so that's the sine function. Okay, next we'll look at the cos function. The cos function is a ratio between the adjacent side and the hypotenuse. Again, if I look at this triangle once more, the cos theta value for that angle there would be the adjacent side is in fact this side here, this side adjacent to the angle. So that's the adjacent side. So that's 4. So that's 4 divided by 5. So cos theta is equal to 4 divided by 5. And lastly, we look at the tan function. Which is a ratio between the opposite and the adjacent side. So the hypotenuse does not feature on this function, so it's the ratio between the opposite and the adjacent. So the tan theta value for this right angle triangle here is opposite of adjacent, so that's 3 by 4. That's 3 divided by 4. Right. Okay, now if you take your calculators out and you work out the angle for which the sine theta value gives a ratio of 3/5, to figure out that angle, what you do is you do 3 divided by 5, and you find the sine inverse of 3 divided by 5. Alright, so in your calculators you'd have to do this. You have to first press the shift button and then press the sine button and then open up brackets and then do 3 divided by 5. Or if some of you are smart, could just say sine inverse of 0.6, which is the result of 3/5. So sine inverse of 3 divided by 5, and you press the equal sign and you get 36.9. That's to 1 decimal place. Alright, so the sine inverse of 0.6 is 36.9. Now I just don't want you to get bogged down with these symbols I'm using. Okay, just focus on the angle here. The angle you got for sine inverse of 3/5 is 36.9. Alright, now what do you think I'm going to do here? Yes, I'm going to find the cos inverse of 4 divided by 5, which is 0.8. And if you did that on the calculator as well, shift cos, open up the brackets, 0.8, which is the answer to 4 divided by 5, I get the same answer. I get 36.9 degrees. And if I do the same here, tan inverse of 0.1 this time, because that's 3 divided by 5, I ought to get the same answer. One second. Yes, no, I've not typed it out correctly, just 1 second. Yes, I got the same answer in fact, so that's 36.9. Alright, so for an angle of 36.9 within a right angle triangle will always give you this ratio. Okay, so even if I change the dimensions of a right angle triangle but I maintain that angle of 36.9, so in this right angle triangle this side is going to be 5 and this side is going to be 4. It's going to be similar to that right angle triangle above, but if I, let's say, double the scale factor, so the scale factor here is 2, so the new length here is 6, the new length here is 8, and the new length here is 10. Alright, let me just correct that, 10. Okay, so that's a 10. Okay, that's a 10. Now if I chose this angle once more, okay, now those of you who know similar triangles rules would know that these two are similar triangles, this small one here and this big one. Okay, so therefore the angles are the same. So if I did sine theta, which is the opposite over the hypotenuse, 6 by 10, which is in fact the same ratio that you got when you divided 3 by 5, which is 0.6. So same result here, so 0.6. Okay, so when the ratio between the opposite and the hypotenuse is 0.6, the angle will always be 36.9. Okay, so you would expect the same for all the other functions as well. The cos function, if you did 8 divided by 10, you get 0.8, and that's what you got when you did 4 divided by 5. So you got the same angle. If you did the tan function, you get 6 divided by 10. Sorry, 6 divided by 8. So that's 0.75. Still the same ratio. So that's a small introduction on sine, tan, and cos. Okay, now I'm going to do something different. I'm still going to use sine, tan, and cos, but in the examples we saw above, I didn't use any angles. I got a result which was an angle, but I only had sides, lengths of sides. So this time I'm going to use an angle. I'm going to call this 30 degrees, and I'm going to say this length is 5, and I'm going to work out this I'm gonna have to work out this side, which is x, the unknown, and I've got to put a little square there to show that this is a right angle, because these rules only apply to right angle triangles. There are some complicated rules, theorems that involve these functions in A levels, but for now you can only use these sine, tan, cos rules for right angle triangles. Alright, now let's see how we solve this. So I've given you an angle here, which is 30 degrees. I've given you a side here, which is 5 degrees. 5, well, arbitrary units, centimeters or meters. We just call that 5 now. And this is an angle 30 degrees. So this side here, 5, is opposite this angle. So this must be the opposite side. And I've asked you to figure out what x is. Now x is the hypotenuse. So the hypotenuse is always the hypotenuse irrespective of which angle you choose. This hypotenuse always is the longer side of a right angle triangle. So the trigonometric function that involves hypotenuse and opposite is in fact the sine function. So I'm going to have to use the sine function here to solve what x is. So sine, this time I know what theta is. My unknown angle is 30, sine 30. Now here the unknown is x. So the opposite is 5 over the adjacent, which is, sorry, opposite over hypotenuse. That's the sine function, opposite over hypotenuse. The hypotenuse is x, the unknown. Okay, so I've got sine 30 is equal to 5 divided by x. Alright, now to figure out what x is, I've got to do a little algebraic manipulation here. You need to be very thorough with your algebra here. So I'm going to have to make x the subject. So I'm going to do it step by step for those who struggle a bit with their algebra. So first I'm going to multiply both sides by x. So I'm going to multiply both sides by x, just to show that whatever I do on one side, I do the same on the other. So I get x sine 30 and I get 5 because these two x's cancel out. Okay, and then I'm going to divide both sides by sine 30. So I suggest you to do these steps when you're first starting out, and then there are some shortcut methods where you could leave out a couple of these steps here. Alright, so I divide both sides by sine 30. So this sine 30 and this sine 30 cancel out. I am left with x is equal to 5 divided by sine 30. And now what I will have to do is work out the value for sine 30. So if I turn on my calculator and type in sine 30, I get 0.5. So that is 5 over 0.5. Again, I tap that into my calculator and I get 10 as my answer. So this hypotenuse here, this side here, is in fact 10 units. So when the opposite side is 5 and the hypotenuse is 10, you'd get an angle of 30. So that means in another situation where if you had another right angle triangle and this angle was 30 and this length here was 12, this side here would be 24 if it is a right angle triangle. You could try it. You could make this the unknown and work out what x is. So if the ratio between the opposite and the hypotenuse is 0.5, then the angle that's involved there is always 30 degrees. Okay, that's it. Thank you.